Hello and welcome to this course. My name is Spyridon Pantelis. I'm a project manager at the European Energy Research Alliance. And today we're gonna look into the European battery research and innovation ecosystem and present an overview of the related cross-cutting topics. The European Batteries Research and Innovation Community is the tagline describing four initiatives collaborating in the battery sector: BEPA, Batteries Europe, Battery 2030 Plus, and the two important projects of common European interest. What makes these initiatives a community is their joint mission to drive European research and innovation in the field of batteries. Their mission is concretized in the co-organization of activities, events, official statements, and the joint publications. Every year, the European Battery Research and Innovation Community co-organizes the Battery Innovation Days, a hybrid event attended by a research community, policymakers, scientists, and industry representatives. During the third edition of this event, the four initiatives have publicly presented their new common visual identity, showing reinforced collaboration and alignment as a community. IPCAs are important projects of common European interest, transnational projects with an important contribution to the growth, employment, and competitiveness of the EU industry and economy funded by state aid. According to the EU Commission, IPCAs make it possible to bring together knowledge, expertise, financial resources, and economic actors throughout the Union so as to overcome important market or systemic failures and societal challenges which could not otherwise be addressed. They are designed to bring together public and private sectors to undertake large-scale projects that provide significant benefits to the Union and its citizens. A two-part IPCA has been implemented on battery technology to promote the battery production. The IPCA on batteries and the IPCA European Battery Innovation, in shortcut EU BATIN. Both IPCAs have in common that their participants represent the entire value chain, from material through cells to the battery system and the final step of recycling. At the same time, there is a high degree of networking between the companies themselves and the two IPCAs. The EU BETIN project is coordinated by the German Federal Ministry of Economic Affairs and Energy with the support of VDI-VDIT. The required aid approval by the Commission was granted in early 2021 with the participation of 12 member states and more than 40 companies. The Battery 2030 Plus initiative is a large-scale initiative that creates a chemistry-neutral toolbox for transforming the way we develop and design batteries. This will provide the EU industry with disruptive technologies and competitive edge throughout the entire battery value chain. Battery 2030 Plus is a family of projects implementing the Battery 2030 Plus roadmap. By coordinating projects and engaging with EU battery platforms like Batteries Europe, BEPA, and the IPCAs that we saw previously, Battery 2030 Plus fosters collaboration across the European battery research community. With regular updates of its roadmap to address emerging research needs, it is dedicated to establishing best practices, creating shared data standards, and developing training materials to unify research efforts. You can see on the screen, on the slides, you can actually download, you can scan this barcode and download the roadmap itself. Another priority of the roadmap is education. And the partners of Battery 2030 Plus shape curricula for master programs and lifelong learning, while encouraging digital education to support the battery ecosystem. Battery 2030 Plus also emphasizes on outreach through events like the excellence seminars and annual conferences, working to strengthen partnerships and drive sustainable battery innovation across Europe. Partnership Association BEPA is the international non-profit association representing the private side of Bat4EU partnership. It gathers the European battery community willing to contribute to the ambitious upcoming Research and Innovation Batteries Partnership under Horizon Europe. The main activity of BEPA is to provide input and advice to the European Commission in order to contribute to the identification of priorities of research and innovation activities and subsequently the definition of core topics to be included in the Horizon Europe work program. Some of its general objectives include the contribution of making Europe climate neutral continent by 2050 through the widespread adoption of electromobility and electrical storage. Other objective includes also enabling European leadership in the battery industry across the value chain, creating economic growth and quality jobs in a circular economy way. It also aims to contribute in achieving zero pollution ambition for a toxic-free environment by providing safer and more sustainable batteries and processes. In this barcode, you can download the latest document of the Strategic Research and Innovation Agenda. Batteries Europe is the European technology and innovation platform on batteries and provides the community with a forum to spearhead research and innovation actions to accelerate establishment of a globally competitive European battery industry. Batteries Europe and the Bat4EU partnership have similar ambition. However, while Batteries Europe aims mainly at identifying in a holistic way all the research and innovation needs across the battery value chain at also every TRL level, the Bat4EU partnership focuses on prioritizing the most urgent research and innovation priorities to be addressed within the Horizon Europe work program. Because of their similarities, the two initiatives collaborate closely. Currently, BEPA and Batteries Europe are working together in integrated working groups and cross-cutting task forces. The working groups cover the entire battery value chain from new and emerging technologies and advanced material to mobile and stationary applications. On the other hand, the task forces cover the most relevant transversal topics related to battery technology, such as digitalization, safety, sustainability, and education skills, etc. The working groups, with the support of the task forces, develop various strategic research and innovation agenda to give unified voice of the European battery research community. Finally, Batteries Europe also serves as an advisory committee in BEPA, facilitating information exchange and coordination between the Horizon Europe partnerships, member states, relevant regions, and other structures directly addressing different parts of the battery value chain. Batteries Europe is an inclusive and free of charge platform aiming at representing at most the battery value chain with experts coming from the different domains of research, industry, and academia. In this slide, I will focus a bit more on the outcomes of Batteries Europe and especially those that were produced in the last 12 months, so mainly 2023-2024. So the first one is the technology roadmap, which aims to identify key research areas addressing short-term needs for between 2027 to mid-term to 2030 with a focus on expected impacts for the battery industry, and this is supported by specific key performance indicators. The other main document that was led mainly by BEPA is the Strategic Research and Innovation Agenda, which prioritizes research and innovation topics to enhance the competitiveness of the European battery sector. This agenda serves as a guiding framework for Horizon Europe programs and future funding opportunities. The other flagship series, I would say, are position papers on cross-cutting topics, which in number there were 6 position papers, which aim to provide strategic guidance aimed at advancing battery technology effectively across various domains. We'll focus on them later. Also, there was a lot of substantial work on the International Observatory, which offers insights through country fact sheets and analysis of R&D efforts in international regions critical to the battery industry, supported by missions to Japan, South Korea, and North America. So in this slide, we will focus a bit more on the cross-cutting task forces, which facilitate the collaboration between the working group members in non-technical thematic areas, which are mainly transversal to the entire value chain. The aim of the task force is to discuss the main challenges in these areas and provide recommendations to support the main work stream of the working groups, taking into account also their specific challenges and needs. The areas that are covered by the task forces are education and skills, digitalization, social science and humanities, safety, sustainability, and hybridization. In the task forces in total, there are more than 360 experts collaborate in frequent meetings. The main objectives of the task forces are to strengthen the battery research and innovation ecosystem by gathering EU stakeholders and fostering discussions on these cross-cutting topics, but across the value chain. They also aim to identify needs, challenges, and barriers that the battery community could face within the prospective scope of its task force. They also contribute to the strategic documents produced by Batteries Europe and BEPA, and most notably the roadmaps, the SRIAs, KPIs, and BAT4EU work program. They also provide clear and concise recommendations for the battery community and policymakers. Especially this one is the main outcome of their position paper that you can download online, and you can also find some video presentations based on the workshops that were organized in June 2024, and you can also download the slide decks of the presentation of these position papers. The benefits of having this cross-cutting approach and looking into the areas that are common to several technologies, and why it's important to include cross-cutting topics in the dialogue. So first, interdisciplinary solutions are essential. Many modern challenges, such as climate change, digital transformation, and public health crisis, require collaborative approaches across various disciplines. Cross-cutting areas like sustainability, digitalization, and gender equality facilitate comprehensive and innovative solutions. Next, holistic policy development is crucial. European research and innovation funding aligns closely with the EU's broader policy goals, including the Green Deal, digital transformation, and social inclusion. Cross-cutting discussions ensure that research and innovation projects contribute to the multiple policy objectives, promoting a cohesive and impactful policy framework. Maximizing impact is another key benefit. By addressing cross-cutting issues, projects can achieve broader societal, economic, and environmental impacts. For instance, incorporating sustainability into technology-focused projects ensures that innovations are not only cutting edge, but also environmentally friendly and socially responsible. Efficiency use of resources is also a significant advantage. By tackling cross-cutting topics, European research and innovation funding can support research that benefits multiple sectors, leading to more efficient research allocation and minimizing duplication of efforts. Furthermore, innovation synergies are fostered. Cross-cutting discussions encourage knowledge sharing and collaboration between disciplines and sectors. This often results in unexpected synergies where breakthroughs in one field inspire advancements in another, creating a dynamic and interconnected European research landscape. In conclusion, integrating cross-cutting topics into European research and innovation discussions ensures that research projects address complex and multifaceted challenges in a more integrated, impactful, and efficient manner. In the next slides, we will have a look individually to each of these cross-cutting task forces on battery technology, and we will summarize their main recommendations, the scope, and what are the key messages from each of them. Skills, which, as you have heard, that in order to meet our targets, our battery manufacturing targets, we will need to train a workforce that is on the magnitude of 800,000 by 25 and almost double than this by 2030. So the scope of this task force is to identify the different educational and training needs across the value chain and operated by different actors, institutions, organizations, and so on. And this includes different types of education and training, from academic education, both master and PhD, but also bachelor degrees, professional level and vocational training, and so on, and at different timelines, short, medium, and long term. Messages from the position paper of this task force, and I start with the fact that there is already a greater awareness for battery sector skills needs since 2020. So it's not a need that surfaced just recently. And this reflects in developments in different segments on undergraduate and master programs, vocational programs, and also upskilling and reskilling, and of course autonomous learning. Then there are future skills needs towards 2030, and the scale of training rollout is increasing through, for example, leveraging online learning. There is also an increased focus on vocational training and workforce upskilling. Of course, there are still several gaps and challenges, and examples of this include train-the-trainer programs, the limited workforce mobility, which actually can be enhanced through the greater compatibility between educational institutes. And some recommendations that they span among three different time frames. The one is short term, up to 2027, then mid-term up to from there up to 2030, and then long term beyond 2030. So in short term, the focus would be to prioritize funding on education along with cross-disciplinary education, and substantial efforts are needed for reskilling the workforce, facilitate the trainers program, and organize more hands-on training. In mid-term, if these are implemented in the short term, it should be developed a continuous certification system, and starts the education in these domains at lower educational level, could be still at a school education level. Of course, collaborative learning and mobility programs are of high importance. And in long term, to strengthen the industry-academia collaboration and focus on competency building and innovation. The task force of education and skills. Of course, these domains are analyzed and they're further expanded and elaborated in the position paper that you can find in these links or scanning QR codes. And of course, you can download the slide deck of and watch the video of the workshop, which actually presents and analyzes these position papers. To the topic of digitalization of batteries. So, cheap renewables, flexible demand, and battery storage will be digitally combined to shift the European power system away from fossil fuels and nuclear power to a cleaner society with variable renewables and emission-free energy. So, this shift in the energy transition will be enabled by smart digital technologies. Digital technologies will optimize the value that battery storage system can bring to the energy market, and thereby enabling opportunities for new energy stakeholders, creating a new generation of jobs for the circular economy, and bring Europe to the forefront of leadership in the fight against climate change. The development of digital technologies is required to improve the industrialization of new batteries and shorten time to market. The design of machine learning algorithms will accelerate the discovery of materials and the development of AI orchestrated characterization of batteries, battery materials, and battery cells. Combining computer-aided engineering tools and experimental measurements will help to understand and predict the performance of the batteries. We should keep in mind that these technologies will continue to evolve more rapidly than the time required for the transformation within the mobility, storage, and battery industry. Is that the task force want them to stand out. So when we speak about data shapes and ontologies, there is also the importance of defining the resulting digital services. When we have defined all these structure, attributes, and ontologies, then we can speak about the use cases that we can deliver and leverage all the experience and data, machine learning, and expertise on batteries. But first, we should have a common data space to benchmark and compare the experiences that we have on, for instance, safety, cybersecurity, and other fields. If we're talking about enabling technologies and we only focus on digitalization only with software engineers, we wouldn't be able to deliver useful services. We need people that understand physics, chemistry, and tech industry, and integration with electricity sector, and those will develop the algorithms and the models. We need therefore to have easy modeling tools, but also different competencies on board. In this respect, we can have an open source centralized repository of automated methodologies, workflows, and protocols with clear and extensive documentation. Key messages here we have digital twins and SOX monitoring. So the digital twin is something that we can have at the level of battery to the level of factory, so at different levels to have a digital twin. These will reproduce continuously the progress of these assets, so everything will be mirrored there on the digital twin of the actual infrastructure or material. So we will be able to do better and more analysis and tests and, for example, performance analysis. Once we have the ontologies, the models defined, and so on, then we can display with some dashboards and analytics the status of everything about the battery. For instance, the cybersecurity, the state of safety, the level of charge and discharge, and other scenarios, as well as the end of life of batteries and when we start recycling and replacing them. So these KPIs are delivered as the results of what has been done in the previous parts. So this is just to collect, to monitor and collect information about the batteries themselves. But you can find all of them within the position paper itself. So we recommend to identify the full digital landscape. This is not about IT, but about the different digital processes. If you're in the manufacturing, you can find business processes on various steps. For instance, in procurement, finance, supply chain management, and so on. All these data should be integrated. To start this, we should move beyond the pilot phases and introduce them gradually to the real processes. Therefore, we should begin at small scale and then start scaling up. Then it's about standardization, which is key, as in several other technologies. And we should identify the areas that should be standardized, for example, interfacing, life cycle assessment, carbon emissions, and so on. Last but not least, we should define who is the owner of each part of data of process reflected on data. So if we have a common repository, you might need to have separate and identified data or operators, and this is an issue that should be addressed. A position paper on digitalization. Of course, like the previous one, you can scan the barcode here and watch the online workshop, download the slide decks, and find more information written inside the position paper, all of them free to download. Mainly battery sustainability. So in this position paper, it was a lot of discussion on considering new framing conditions. For instance, the Critical Raw Materials Act, Sustainable by Design, Net Zero Industry Act, and the new battery regulation. All of them have some sustainability aspects that provide really interesting information to frame the sustainability on battery technology. We also have a comprehensive look on sustainability, considering not only the present but also emerging batteries across the entire value chain. And these would also help developing new ideas and options to foster a more sustainable battery ecosystem in the future. This position paper. So in principle, we totally agree that the new regulation, together with the passport, is the most important guiding framework for the sector, including recycling targets, even if they will be challenging in the future. Yeah. CO2 footprint is a good starting point, but there should be more indicators and to broaden to include more sustainability indicators. We also see that in the regulation, the second use of batteries is not well addressed, and this is something that we highlight in the position paper. Then sustainability, as I mentioned before, is a cross-cutting topic across three dimensions, which embodies the environmental, economic, and social dimensions. And sometimes it's difficult to and it can create conflicts. Some technologies, for example, might be good from the economic perspective, but are, for instance, higher in toxicity. Such conflicts should be addressed and ideally supported by a framework. On economic sustainability, the life cycle costs is the tool that we would prefer from the life cycling thinking perspective. But of course, there are the other tools to assess economic sustainability. On the social sustainability, the SLCA, or social life cycle assessment, is the most sophisticated tool. There are still some problems with the databases, which is a critical issue, but the framework is there. SLCA are just one way to assess the societal impact, and it should be definitely expanded to include also quantitative indicators, which is sometimes might be a challenge to have more objective view on it. So on the last part, the environmental sustainability, at least for batteries passport, the CO2 footprint is the most dominant, and we should include more information in the future. Toxicity is a tricky topic on how to access in a good manner the toxicity of a technology. So resource demand is critical, especially if we focus most of battery products in lithium chemistries. Another topic is the second use of batteries in terms of circularity that has to be addressed more than it was in the past. And last part, but equally important, is that we should better address the methodological challenges and possibly have some harmonization in the future. And this is a quite important part. Are the following. So starting with a common assessment framework, so this means that a standardized assessment is needed to evaluate battery sustainability, looking at economic, environmental and social impacts across the battery life cycle. And these frameworks should apply to all battery chemistries. Then about uniform reporting, which is an essential. So it should help ensuring consistent reporting on environmental performance, and will enhance transparency and comparability across the industry. Another topic are the data standards that must be set. So it's crucial to define standards for transferring and handling sustainability data, with an emphasis on environmental information and data privacy. Then it's the guidelines for sustainable production and recycling. And here, developing guidelines based on best available techniques will very much help improve sustainability in battery production, but also on the recycling process. Another recommendation includes we should promote eco-friendly and socially responsible practices, and encouraging green production, recycling, and of course, we should not forget the human factor. We should support employee and societal welfare as they are key for long-term sustainability. And the last one is it's important to engage with key stakeholders and collaborating with different players from academia, industry, different parts of society, but also NGOs will be critical to assess sustainability challenges. And of course, one of them is the so-called PFAS or forever chemicals. With the rest of the task forces, you can find the online workshop online and download the position paper, and all of this information is free to access. And this is actually a new task force in a topic that is less explored compared to the other transversal topics that we presented before. So what is the scope of this task force? First, strengthening interdisciplinary collaboration. So this task force aims to integrate both STEM and SH disciplines into Batteries Europe, helping to identify the critical research areas. Second, aims to raising societal awareness. So it focuses on highlighting the human and societal impacts of the battery value chain. Third, it aims to enhance societal understanding. So it seeks to deepen insights into various societal dimensions of batteries across Europe. And finally, to engage key stakeholders. So this includes fostering discussion on societal impacts within the batteries platform. As I say, in batteries, we use Scopus as a tool, and we overall identified 153 papers. So the objective was to, first of all, understand what are the gaps and which areas have been in focus when we talk about SSAs. And below you can see some key messages from these, I would call mini research. So exploring the intersection of SSH and battery technology. So social science and humanities, or SSH, offer valuable insights into battery technology, especially by analyzing components and life cycle stages mainly. Second, the current research is focusing very much to the economic and sociological aspects, but without paying much attention to the rest. You can see on the graph also the more dark hue of green. Then the research gap has been identified, so notably there is limited research on transport and distribution stages, and also adopting a life cycle framework is effective. So using a product life cycle approach helps integrate SH perspectives, providing a more comprehensive view. There is limited research in battery SSH relation, and there is a missing structure, form or process to facilitate this. So also there is limited research that combines STEM and SSH perspectives effectively. Then focus only on the use of batteries, and there is a lot of focus on the use, and at limited extent to the mineral extraction, for example, which is it's a high concern also addressed in the battery regulation. And last, there is not much focus on widening EU countries, and they don't go beyond yeah, beyond the wider impacts of competitive value chain, and this would be more focus on attracting more EU13 countries to participate in these domains. Download the position paper, watch the workshop and the recording there, and download the slide decks as well. Position paper was to identify the upcoming safety challenges, but along the whole battery value chain, from material level to cell pack system, safety end of life, and testing procedure as well. So each battery technology has indeed its own safety specificities and associated risks, ranging from simple battery failure to more serious events such as thermal runaway and explosion. So even though safety should be tackled in all battery technologies, in this report we focus mainly on the chemistries of lithium-ion batteries, simply because it's widespread utilization in everyday life devices. First of all, safety should be considered from the perspective of the whole value chain. So it's there are different concerns at different steps of the value chain that we should focus on. Establish and maintain databases for battery-related incidents should be maintained. And this is a real plus for the entire community when those databases are available, because they can be used to check whether new systems are safe compared to related incidents, something that is not yet in place. The other point is that safety KPIs that should be developed to and bring them all the way to standardization. The last one is that there is a need to train and educate the workforce in all safety aspects, and there are still several gaps across the value chain on these, and improvements should be made. Sensing technologies have been recognized for their benefits in various fields for decades. In the context of batteries, the ability to monitor and gather data on chemical, thermal, and mechanical parameters will be crucial for ensuring safety and efficient operation of batteries. There's also an expectation that they expect increase of the cell production and EV market size at the European level will increase demand for testing capacities, and a reduction in test duration and costs is crucial to allow a fast market access and increase Europe's competitiveness. So testing should be complemented by safety models, simulation tools, and safety guidelines for all academic, technical, and user profiles. About new emerging technologies, so they may result in major improvements in safety, and there is already a lot of research done in this direction today. And for these, the safety assessment for materials and their compatibility should become a part of every new material development. At the same time, novel materials or technologies of future battery generations could bring new hazards, and of course this is an element to be considered, as well as new chemistries become to the commercial phase. So research and development are needed to provide digital safety tools, simulation and modeling at all levels, and in order to achieve the high level of safety that is needed for the acceptance and increased use of batteries. Then it's very important to stress that robotics and the automatization of processes is clearly seen as a key action for several parts of the battery value chain, such as manufacturing, handling, transport, recycling, and storage of waste and damaged or defective batteries. Automatization of processes should be designed to improve the outcome of the process and tests, avoiding human interaction and decrease the test duration. In this regard, together with automatization and robotics, this digitalization is essential. Paper you can download it together with a slide deck and the online workshop by scanning these links. Of this task force is focusing on the hybridization of batteries and not energy storage in general, as a storage project does. Therefore, its scope is limited to battery applications only. When we talk about hybridization in batteries, of course, there are different systems of hybridization. There might be heterogeneous, for instance, to combine a high power cell with lower power cells or different battery chemistries of lithium. You can think of hybridization at micro level, for instance, in the future in an aerospace sector. You might rely on sustainable aviation fuel, the so-called SAF, for propulsion, but you might also rely on battery system for landing gear, air conditioning, and other systems. Other systems might also include a cross between a battery and supercapacitor, electrolyzer, and a battery, and so on. So the reason why we hybridize battery systems is for bringing additional benefits that one technology cannot reach by itself. And these benefits, as they might be outlined in the other presentations of storage partners, but these can vary from cost, performance, flexibility of the system, some that has to do with lifetime of battery, improved reliability, sustainability, energy security, and so on. So the hybridization of a battery system might bring various benefits. First one is on grid booster. So for long-term energy storage system, you might want to combine redox flow batteries with high-power lithium-ion batteries. In this combination, you might even be able to extend the lifetime of the battery by hybridizing these two systems and have key functionalities such as rapid response capability, high capacity, and longer utilization of grid booster. You can of course include seasonal storage if needed. So in this regard, we have identified several research needs. But let's explain the first one a bit. So typically, transmission lines operate below their full capacity to allow for the dissipation of energy and alternative lines during emergencies. In a grid booster concept, the safety margin of transmission is utilized to transfer more energy over the existing power lines and instead utilize battery storage to be the safety margin in the transmission line. Therefore, the batteries in a grid booster offer an alternative safety mechanism. In practice, large-scale battery installations can be replaced at central connection points along the transmission line to absorb this excess energy during emergencies, while transmission lines operate at their maximum capacity. This concept can, in principle, also be added up with other services of the grid operator. So there is a need to showcasing both flow and lithium-ion batteries as grid boosters, with a focus on studying cost implications. Next, we will need to create digital twin of the grid. This digital twin will incorporate hybrid energy storage systems to enhance grid planning and analysis. Lastly, there is a need to create actionable business cases and policy recommendations, but nationally and across European borders to support these technologies. Hybrid battery storage. In a neighborhood, you can imagine a storage system that can cover a village or a neighborhood. There, you can consider a system using redox batteries or lithium-ion batteries, or a community with many electric vehicles. In this case, it might be different lithium-ion chemistries. So in such setup, we need more research on developing advanced battery management systems and diagnostics for both stationary but also for mobile battery-based neighborhood batteries. Then we need to understand better how the electric vehicles function as stationary batteries, and we need to understand better the energy management and the ancillary services that they can provide. We should be able to also to manage the system together and consider that different battery chemistries might come from different EV manufacturers. Of course, peak shaving can be taken over by high power technologies, while energy storage can be given to the one that has high energy storage capability. This is in a hybridized battery system. So this means that combination of high power packs and high energy packs can mean that intensive power burst operational modes can be handled by the high power packs. So for example, the peak shaving, while the large energy demand being met by the high energy density storage schemes. You can find online together with the slide deck and the workshop. Of course, in case you have any questions, you can find my contact details here. Don't hesitate to contact me and reach out to our community through my mail. Thank you for your attention.